Just waiting to maximize the screen. Okay, we're going to actually use a very similar example to what we started with when we first factored trinomials. We have an array here of 3 rectangular solar panels, and it has an area of 3x squared plus 21x plus 36. We know the height, and we're going to find the length. Okay, just like any other rectangle, we're going to calculate the area by multiplying some binomial, a length, times x plus 3, and we're going to end up with a trinomial 3x squared plus 21x plus 36. Okay, now we went over in a previous lesson how we knew that the length could not be a constant and a monomial. Or we talked about that when we first multiplied. But now we want to figure out how could I determine what the length is. So let's start here in this example. We could just figure out what we did to get 3x squared plus 21x plus 36. Imagine having a binomial, 2 terms, and we multiplied it by x plus 3. And we ended up with 3x squared plus 21x plus 36. Now imagine that binomial. Okay, we're going to have a process for this, but right now you were given one of them. What could I, if I foiled and I multiplied the first term from this binomial times the first term from this binomial, and I got a 3x squared. What did that missing term need to be? It had to be a 3x because I know if I'm working backwards, that something times x gave me 3x squared. It has to be a 3x. And then we could just use this last term because when I FOIL, if I multiply the last term by the other's last term, here I would have gotten a 36. So what must that term be?
12.
Must be a 12. Now you're not always going to be given one of the binomials, but you can see how when we factor, we really are just doing the opposite or the reverse of distributing the value through, or like we did in class before, foiling. So this was factored a little bit further, but as we go through, we would have ended up with 3x plus 12 based on how we're about to factor. Okay, so let's talk about another example, okay, that we're going to do start to finish. We're going to go through everything, and then we're going to backtrack and see why we did what we did. So let's take this trinomial, 6x squared plus 23x plus 7. We are going to rewrite that. We're going to rewrite and break out that 23x, and we're going to rewrite it as 21x and 2x. And I start to add in some color here so that you can see how we broke it up. And what did we really do? We took this trinomial and we broke it out into this format. If you recall, when we multiply or FOIL, if we multiply 2 binomials, we do actually have 4 terms. How do we end up with 3 terms when we simplify? Wait, how do we go from these 4 terms when we FOIL out to just a trinomial? Because we end up combining those two inside terms. So here we actually want to go back to that 4-term polynomial because we're going to be able to factor out that way. Once I have this polynomial, this 4-term polynomial, I'm going to find the greatest common factor of the first 2 terms, which is here in red. And then I'm going to find the greatest common factor of the second 2 terms, which is there in blue. Again, for those of you who like to do the distributive property when we multiply 2 binomials, if we multiply the first term times the second parentheses, which represents the F and the O of FOIL, and then the second term, we'll do it like this, times the other parentheses. Really, we're undoing that. We're doing the reverse of FOILing or distributing, depending on how you multiply. So what do you notice? At this level here, once I've factored out the greatest common factor of the first 2 terms and the greatest common factor of the second 2 terms, what do you notice about the parentheses? The terms in the parentheses, I should say. Remember, we're factoring right now. They're the same. Both of those parentheses contain a 3x plus 1. Imagine, and I know I'm asking you to tap back into your multiplication. If you were FOILing, you would multiply the first term of the binomial times the entire second binomial. And then you would take the second term of that binomial, and you would also multiply it by the other binomial. So we're really, again, we're undoing. You're going to learn a process for this, so don't worry. After I break this out, what am I left with? One of the binomials is 3x plus 1. The other binomial is made up of this 2x and this 7. Let me erase some of this. So that would be how factoring is done. You have yet to see the process, but I want to ask you now, some of this should make sense. What I mean by that is you understand how to multiply two binomials. And we have been working a little bit on how factoring is the opposite of that. So some connection would be made, like, okay, I see why we would take out the greatest common factor if when we distributed, we multiplied one thing through every term. What I want to know right now is from this process here, where we start with the trinomial, we break it up to a polynomial, and then we find the greatest common factor to get an answer. What part of that right now seems unclear as to why we did what we did? It's all new, so it's all going to be a little bizarre. But what part, at what level are you like, I could... Because some of you might look and you're like, I can see why we would do that. I've never done it before, but I can see why. Is there any area of this where you're like, I don't know why you did that, like that exact thing? Anything as you look?
Are you saying to multiply the 2x by everything inside of the parentheses for the red or for the blue?
Now we're undoing. Imagine we started with these two binomials, and I said to FOIL it. What would you multiply? 2x times? Okay. And then what?
The 2x by the 1.
Okay. And then what would you do?
3.
Okay. So that's what we would do to multiply. We would multiply it through. And then at the end, we would combine our like terms, and we would end up with 6x squared plus 23x plus 7. Now we're doing it in reverse. You're going to start with the trinomial, and you're going to break it out, and then factor out, and then finish. But there's something here. We're going to go through everything, but I wasn't sure if some of you might see, like, I can kind of follow it, but there's like one thing. Because there's one thing here that when we get into the process of factoring, we add in that I did not explain.
Not understood. How do you go from that 6x squared plus to the bottom?
To this?
How do you go from that to the one at the very, very bottom? Like, how did you?
So from this level, we're going to go through the entire process, but from this level here, once I have it broken out, I'm going to factor out the greatest common factor of these two terms and the greatest common factor of these two terms, leaving me with one binomial and then the other binomial was what I factored out. So the real question that I was hoping would pop into some of your minds is how did you go from 23x to breaking it out to 21x and 2x? Because why didn't I break it out to 15x and 8x? Why didn't I break it out to 20 and 3? There's a reason why we would break it out that way. And that's where the process, the actual procedure of factoring the trinomial with a coefficient greater than 1 comes into play. So if I multiply 21 times 2, if I multiply these two numbers, what do I get? I get 42. What if I multiplied these two numbers?
42.
I also get 42. So when we factor, this is what I'd like for you to write down, when we factor a trinomial of the form ax squared plus bx plus c, a is the coefficient of our x squared, b is the coefficient of x, and then our coefficient of our constant c. We are looking for factors of the product of a and c that would add up to the middle factor. I'm going to go through the whole process. So using the example that we had, the reason we came up with the 21 and the 2, I first multiplied the coefficient 6 and the constant 7 to get 42. From there, I'm going to factor 42 and find the 2 factors of 42 that add up to that middle term, that add up to that 23. I know my factors here are 21 and 2, so I'm going to rewrite this as 21x and 2x.
So is the middle number always going to be a multiple of 40? I mean, of any number? Like the ones that you multiply outside, which you get.
You'll be able, as long as it is factorable, you will be able to find a combination. And this one, these are both positives. We're going to go through an example where you might have to use a negative. But yes, when we get into our next unit, when we deal with solving quadratics, some of them we may not have a solution. That will be different. These that when you're learning to factor, you are going to have ones that will factor. Now, once we have these 4 terms, we're able to factor out the greatest common factor because, again, this is the result of FOILing. I multiplied the first term by an entire parentheses to get this F and this O, this one term and 2. So what one term did I multiply by both things inside to get 6x squared plus 21x? What is common between them?
3.
A 3, and what else?
X.
And an x. Okay. If I took out the 3x, what's left?
Oh, 3. I mean, 2
2x
plus 7.
7. Good. Now, in this situation, is there a common factor between 2x and 7 besides 1? No. So that would be your common factor would be a 1. So if I factored out in reverse, I actually have the binomial 2x plus 7, and I have the binomial 3x plus 1, because that's what I actually multiplied by 2x plus 7 to get my trinomial. The more you understand the multiplying out, the more you will understand the reverse of it, which is why we start with multiplication. If you're writing something down, continue. We're gonna do another example, and I want you to see how negatives come into play here. But the process is still the same. Now, for those of you who are thinking, we learned a way to factor last week, factors of the last number that add up to the middle number, but now we have a different way. The wonderful thing for those of you that might need just one process to focus on, this works if your coefficient is 1. I can give you an example over here on the side. A common example that we would have done last week would have been x squared plus 5x plus 6. We factored that last week. If I wanted to use this method, I could. I can multiply 1 times 6 and get a 6, and then find factors of 6 that add up to 5, which would be 3x and 2x. And then I could find the greatest common factor here and the greatest common factor here. I would factor out an x, leaving me with x plus 3. And I could factor out a 2, leaving me with an x plus 3. So my 2 binomials would be x plus 2 and x plus 3. If you know if a lot of processes all together would confuse you, if you need one method, this method will work whether you have a coefficient of 1 or a coefficient larger than 1. Last week, when we started factoring with just the coefficient of 1, we were just finding factors of 6 that added up to 5, and we ended it like this. That's what we did. But now, you're going to have trinomials that have a coefficient, so we have another option. That option, this process here, will work if your coefficient is a 1. It's still the same thing. So for those of you that need one method to really focus on and practice and master, this would be it because it will work for any coefficient for a trinomial. So let's take a look here. Knowing what we have, if we have to factor 5x squared plus 11x plus 2, We need to find factors of a times c. What's a times c here? 10. 5 times 2 is 10. Factors of 10 that add up to 11. 10 and 1. So I can actually rewrite this trinomial as 5x squared plus 1x plus 10x plus 2. I didn't change the value in any way. I just broke out that 11x. Again, I have FOIL. When my trinomial is done, I have 3 terms. I need to actually break it back out so that I can find that greatest common factor, so that I can factor out that binomial. From this level, what could you factor out? Help me factor out and finish factoring this. What could I factor out of 5x squared plus 1x? Just an x. Yep, that's all they share. Now, if inside this parentheses I have a 5x plus 1, what must be in this parentheses? It's got to be the same. So what must that greatest common factor be?
Like 2.
Think about what did I multiply by to get 10x plus 2? Multiply by 2. Which means my 2 binomials, x plus 2 is one of them, 5x plus 1 is the other. While this is brand new and you have yet to practice one on your own, what part of this do you feel is going to trip you up the most at this point?
The x plus 2.
Yeah.
The x plus 2 thing. At the end? Like this? Just
Yeah.
figuring out what
Yeah.
the binomial is?
Yeah.
Okay.
No, like,
Like-
maybe we'll put like 5x plus 1 2 times instead of
Like
5x
where
plus
where exactly are we getting it from? Like I can see it in the problem, but like how is it like?
Oh, I
Wait, would you mean, do you mean why is it an x and why is it a 2? Or do you mean why are we taking out the greatest common factor?
in the top there's plus 1 and plus 1, but where did the 2 come from in the bottom?
Yeah, like where exactly is everything like coming from?
Okay, let's try to go through this. I'm going to start with the answer at the bottom and then try to work backwards. Sometimes it helps because you know how to FOIL where it comes from. Okay? If I had x plus 2 times 5x plus 1 and I wanted to multiply it out and get the trinomial, what would I multiply?
X
I would
times
multiply x times what?
5x.
And then
X times 1.
does that represent x times 5x and then x times 1? Yes, it does. Good. Then what would I do?
You do the 2 times 5x.
I would do the 2, this term here, this 2, times
5x.
the 5x, and then what?
2 times the 1.
Right. Does that represent the inside of FOIL and then the L of FOIL?
Yeah.
Yes. So now here, if I actually did multiply that out now, I would get 5x squared
Mm-hmm.
plus x, 1x, plus 10x plus 2. And then from here, I would combine all my like terms to get that. So now let's rewind it and see in reverse like why we would do that.
Oh.
At this level here, what are you multiplying by 5x and also multiplying by 1? The same term, it's an x. So I know once I multiply through, that would be the greatest common factor because I can take it out. If I multiplied it through and distributed it, the opposite of distribution would be factoring. That's why I'm able to take it out because they do share that common term. And then from this 10x plus 2, I multiplied that 2 by 5x and by 1. So again, making it a common factor. By taking out those 2 common factors, you have found the first binomial. What they multiply by is your second binomial. And thus, that would be your answer if you had to factor out the binomials. Does that make a little bit more sense when we do it and then undo it? The answer here, if we had to factor that trinomial, the x plus 2 times 5x plus 1. Those would be the two binomials. And that would be your answer, because right now if you're just factoring the trinomial, you're finding the two binomials. How would you check that? Oil. Yeah, you could actually multiply through and make sure that you end up with 5x squared plus 11x plus 2. Do you have a question?
So you're basically just adding the two greatest common factors.
The greatest common factors of both are the binomial that was multiplied. Yep.
Oh, I see.
Okay, let's try one more. Okay, because I want to show you how this is when it involves a negative. And then the easiest thing for you to find where you're going to get stuck, if anywhere, is to try one. So we'll go through this example here, not this one, this one, and then we'll keep going. So now notice, what do you notice about this trinomial? We have a negative, good. So we need to figure out the factors. First we have to multiply. What are we going to multiply based on this trinomial?
15 and 3.
What kind of 15? That's a negative 15. So we're going to multiply here the C value and the A value to get negative 45. And we need to find factors of negative 45 that add up to a positive 4. Now you can see in the table I broke them all out. If I know that I'm multiplying two numbers and I end up with a negative, one of them is positive and one of them is negative. So you might have to play around with some combinations, especially if you have a number that has a lot of factors. Now I broke out the table, which is handy if when you're first learning this, to break out the factors, which you can. 45 times negative 1, negative 45 times positive 1. Then we have 3 and 15, 9 and 4. 9 and 5. Just leave that one. The only one that gives me a combination of a positive 4 would be here. So how could I rewrite my trinomial? Because those are not my answers, right? I need to actually rewrite my trinomial as a 4-term binomial, or polynomial, sorry.
3x squared plus 2x.
How am I 2?
Oh.
Remember, these are the combinations that will add up to 4x. So, minus 5x plus 9x
Yeah,
minus 15. Just
Did a
now, I want to go with this. 3x squared minus 5x plus 9x minus 15. Do you think it matters? Does the order matter? What would the greatest common factor be of these two terms? An x. What's left?
3.
What's the greatest common factor here?
3.
What's left?
3x.
Now let's try this one. What would the greatest common factor be here?
3.
Just the 3?
3x.
What's left?
3.
Oh, sorry, that's the square.
1.
What's the greatest common factor here?
3.
5.
Negative 5.
Oh. Negative 1.
What's left?
X. Subtract the plus 3.
So notice here it doesn't matter which order you put the 9 and the negative 5. Your answer would still be x plus 3 is one of the binomials, and 3x minus 5 is the other. If you changed the order, that would just represent using a different binomial to multiply through the other one. So the order there doesn't matter. Whether you did the negative 5x plus 9 or the positive 9x minus 5, you would have gotten the same answer. Do you want to try one?
Yeah.
Thank you for your enthusiasm, David. We already did that. Okay, let's try this one.
It sounds like it's a partner depression. Someone like
Not depression. All right. So again, this is a process. You will get better at it the more you practice. So right now, I'm most concerned with if you're going to make mistakes and errors and have confusion, where is that happening? So take your time. Write it down. Give it a try.
Here I go with this. Miss Carolina.
Yeah.
Can I like ask?
Ask or go over?
Yeah, ask.
Yes. So now what would you two trinomials be?
Now I'm lost.
Think about it, you already have the one. You
Uh-huh.
factored out the other. Are we ready to try and go over it? Alright, should we try it? No. Oh, okay. No, wait. Well, stop playing with your watch and go for it.
I got it.
Wait, and you already said on seven. You can. You get it for a moment and then forget it.
I'm gonna be fine at this point.
Me neither.
I'm gonna have to I don't know what
I'll go over everything. Okay, let's go over this trinomial.
Like this?
What am I going to multiply?
6 and 5.
6 and 5. If I multiply 6 and 5, what do I get?
30.
30. Now I'm looking for factors of 30 that add up to 13.
10, 3.
10 and 3. So I'm going to rewrite this trinomial as what?
6x squared plus 10x plus 3x
Write down, please.
plus 5.
Now, what is the greatest common factor of my first two terms?
2x,
2x.
What am I left with?
3x plus 5.
What do I know this parentheses would have to be?
3x plus 5.
So what must my factor be?
Y.
plus 1.
So that means our answer are two binomials that factor out. This is one of them. This is the other. This makes up the other binomial.
I got it.
Where did we get caught up a little bit? Because oh, I'm sorry. Go ahead. If you're willing to share, you're going to probably repeat something that another person's struggling with. Okay, Zara,
I
go.
have a question.
Okay.
30.
Yes.
Why do you multiply the 6 and the 5? Why not the 6 and the 13 or the 5 with
The 6 and the 5 are multiplied because we need to find a way to actually get back to this 4-term polynomial. So the middle term needs to be broken up. So we're going to use the other two terms.
I was gonna ask the same question.
Go ahead.
When I found out what the 10 and the 3 were, I didn't know what to do with it. Like
The 2x and the 1.
no, when we multiplied the 6 and the 5 and then to find what the 10 and the 3, I didn't know what to do with it after that.
A lot of times when people use both strategies, whether we have a coefficient or just a coefficient of 1, greater than 1 or 1, a lot of people will take that 10 and 3 and will just make that the second term by accident. Right? So what I want you to keep thinking about is our goal here is we are doing the opposite of foiling. We are reversing the multiplication. So somehow we need to get to this 4-term polynomial. Hopefully that will help remind you that that 13 will be rewritten. Over time it will get easier because that is part of the process.
Okay.
Anything else that got us stuck? Actually factoring, yeah. Finding those factors that will add up to 13, that's always going to be something that's going to take you a little bit of time, especially for numbers that have a lot of factors. Right, 30 could be 10 times 3, 15 times 2, 6 times 5, there's a lot. And that will always take a little bit of time, something that you'll get more comfortable with as you go. One more? 10x squared plus 31x minus 14.